Hello friends, in this video we'll be solving a simultaneous equation using a non-standard approach. And why are we using a non-standard approach? Well, for a simultaneous equation, a standard simultaneous equation actually, you can use two methods which are substitution method and elimination method. Obviously we can't use the elimination method here because there's no way you either add or subtract these two equations in order to eliminate either x or y. But we can use substitution method because it's possible to make x subject of formula from equation 2 and then substitute it in equation 1. Just that the process will be very lengthy and we don't want a lengthy process now, do we? So we are going to approach this question from another angle that will make it easier and less time consuming for us. Let's start with equation 1. So if you know your algebraic identities well, then this sum of two cubes should make you remember that just as we can write difference of two squares like this, we can also write sum of two cubes like this. And from equation 2, we know that the quantity x plus y can be written as 3/4 times xy. Now it should make sense if you divide both sides by xy, as long as xy is not equal to 0. And why is that so? In mathematics, anything divided by 0 is undefined. And if xy is equal to 0, then when we divide by xy, our solving would become indeterminate or undefined. Okay, now we've cancelled out xy, we can still divide both sides by 3, and to clear this fraction here, we can multiply both sides of this equation by 4. These two 4's can cancel each other out to leave 1, and 1 times everything here wouldn't change anything, and 3 times 4 is 12. At this point, there's nothing much you can do because 12 is 12, you can't change that. But as for this part, it looks like the expansion of x plus y quantity squared or x minus y quantity squared. The only difference is in the middle term, and we can take care of that by subtracting 3xy here, because 2xy minus 3xy is minus xy, or we can add xy here instead because minus 2xy plus xy is minus xy. Of course, since we introduced minus 3xy and plus xy in the right hand side of these two equations, then we'll have to balance it out by introducing the same things in the left hand side as well. Now there's no difference between this expression here and these two equations, so we can successfully replace this expression with any one of these. But which one should we choose? If you looked carefully, then the answer should be apparent, since we know that from equation 2, x plus y can be written as 3/4 xy. I can now distribute the square, and since every single term in this equation is divisible by 3, we'll then have to divide out by 3. And to clear out this fraction, we'll have to multiply both sides of this equation by 16. And we can now bring 64 over the equality sign. You can also think of it as subtracting 64 from both sides of this equation. It doesn't really matter. But at this stage, it should be clear to you that this is a quadratic equation. It would even be clearer if we let xy to be equal to m. And since it's clear that this is a quadratic equation, we can just go ahead and use the quadratic formula to get the value of m. I read the quadratic formula as minus b plus or minus square root of b squared minus 4ac all over 2a. I stress the all over because I've seen people applying the division operation to only this part, whereas it should be applied to everything. Now we just have to plug in the values of a, b, and c in order to solve for m. Minus times minus is plus, which we can omit. Minus 16 squared is 256, 4 times 3 is 12, and 12 times minus 64 is minus 768. Again, minus times minus is plus, and 256 plus 768 is 1024. Then square root of 1024 is 32. And finally, 2 times 3 is 6. So we have that the value of m is either 16 plus 32 all over 6 or 16 minus 32 all over 6. This one would simplify to 48 over 6, which is 8. And this one would simplify to minus 16 over 6, which is the same thing as minus 8 over 3. Now, remember that we allowed m to be equal to xy, so we can now replace m with xy. because obviously from the question we are not looking for m, but for x and y. Okay, now that we've established that the value of x times y is either 8 or minus 8/3, then that goes to show that the value of x and y for both of these equations are not the same, because obviously the same number cannot multiply itself to produce more than one result. So we have to find the value of x and y for both of these equations, and we can start by making x separate of formula in both equations. Now for this equation, we can substitute for x in equation 2. And remember that xy is the same thing as 8, so we can plug that in as well. 3/4 times 8 is 6, and we can clear this fraction by multiplying everything by y. Then if we bring 6y over the equality sign and rearrange, we'll have that y² minus 6y plus 8 is equal to 0, which we can solve by factorization. To give that y is either equal to 4 or y is equal to 2. And to get the corresponding value of x for these two values of y, we just have to plug in each of the values of y into the equation for x. We can do the same thing for minus 8/3y as well. And for this one, xy is equal to minus 8/3. 3 can cancel 3, and minus 8 divided by 4 is minus 2. We can now clear this fraction by multiplying through by 3y, and then bring minus 6y over the equality sign and rearrange. We can use the quadratic formula again to solve for y. 6 squared is 36, 4 times 3 is 12, and 12 times minus 8 is minus 96. Minus times minus is plus, and 36 plus 96 is 132, and finally 2 times 3 is 6. You can leave it like this or write it in decimal form, or you can even choose to simplify further, because the square root of 132 can be simplified to 2 root 33. We can now factor 2 out in both the numerator and denominator, and then divide out to have that y is either minus 3 plus square root of 33 all over 3, or that y is minus 3 minus square root of 33 all over 3. And to get their corresponding values of x, we just have to plug in each value of y in its equation for x, and then solve to get the value of x. Now, bringing our answers together, we have that the solution set for the simultaneous equation we were given is these. And that brings us to the end of this video. If you found this video interesting, then please like this video and subscribe with notifications on. That way you'll be able to see more of my videos when I upload them. Anyways, thanks for watching this video. Have a blessed day. Bye.